Okay, so what we have here is we have a grid with two parts of a problem. We want to take triangle ABC and we want to dilate it about the origin by a scale factor 2. That means we want to make it twice as big. And so for doing this right here, well, it's about the origin, just multiply ordered pairs. The SF, right? So if this is location is 2, 3, right? So A is becomes A prime by 2 times. So if this is 2, 3, A prime is 4, 6. So over 4, here's A prime. It's also where B is. And B is at 4, 6. So it becomes 8, 12. That's B prime. And C is at 1, 2, 3, 4, 5, 6. 6, 4. So it becomes 12, 8. So let's go 1, 2, 1, 2, 3, 4, 5, 6, 7. Let's see. 1, 2, 3, 4, 5, 6. 1, 2. Here's C prime. B prime has to go over 1, 2, 3, 4 and up 1, 2, 3, 4, 6. And here is B prime. Now, let's take a look at this shape and watch what happens. I'm going to put a point at the origin. And now I'm going to extend, oops, this shape went off to the side, but I'm extending the shape through the vertices. So, and then C went from here to here, right? Notice that from the origin, when I connect the points from the origin to B prime, it goes through B, and from the origin to C prime, it goes through C. And so when I take a look at the new shape, right, this is where it extended through, but A prime is here, C prime is here, and B prime is there. So watch what happens when I connect A prime to C prime, just so we get an idea. There. So notice this triangle here, ABC, is half the size of A prime, B prime, C prime. But what's fascinating is that they are both on this triangle here, this big triangle. So dilating a shape through the origin is just multiplying it by 2, or multiplying it by the scale factor. But what if I want to multiply or make the shape 3 times the size from point C? Okay, so part 2 is a little bit more tricky, but one thing we can do is we can kind of think about the relationship from here to here is over 2 up 2. So I want to do that 3 times. So I'm going to go over 2 up 2, over 2 up 2. And so here is where C double prime would be. What about if I'm dilating about point C, so C should stay the same, right? So this is B prime. I apologize, B double prime. And A double prime, so from C to A. So it would also go over 1, 2, 3, 4 down 1. So 1, 2, 3, 4 down 1, 4 down 1, and it would end up way over here. So this would be A double prime. And so now when I connect these points, right, you can kind of see how it got much bigger. and I'll connect this point to here, and then this point to here. But what you can notice is that this segment CB right here from C, this is C double prime and B double prime, but that's 3 times the length of CB, and A double prime C double prime is 3 times the length of AC. So you can kind of see that when it's dilated about a point that's on the shape, the segment is just multiplied by that scale factor, versus the ordered pairs when it's dilated about a point or about the origin, you just multiply by those ordered pairs. Now, we can pick any point and dilate about any point using this origin just by changing the location of the origin. That can get a little tricky as to what I mean. So I'm going to quickly sketch an example of that, and I'll make it another quick sketch. It won't take long, but let's say I have this shape right here. We'll make it kind of a scalene triangle and put it in the first quadrant. It doesn't really matter which quadrant it's in, but I'm putting it in the first quadrant just to stay consistent with locations, although it doesn't make a difference. A, B, C. But what if I wanted to dilate it by a scale factor about a different point that's not on the shape, right? And we'll call it, of course, X and Y, but that's somewhere else on the graph. So let's say I pick this point. We'll say Q. Let's say I pick Q. I want to dilate it by a scale factor of about, I don't know, let's say dilate scale factor of, we'll say 3, right? 3. About point Q. Well, this is actually relatively simple. What we want to do is think about Q as the origin, right? So if Q is the origin, then A's location is 1, -2, right? 1, -2 if Q is the origin. And B's location would be 3, 0. And C's location would be 4, -1. Assuming Q was the origin, right? So if Q is the origin, and these are the locations based on this Q, then we can just apply the general rule that we learned, which is to multiply them by the scale factor. So A prime would become 3, -6. And so from Q, I would go over 1, 2, 3, down 1, 2, 3, 4, 5, 6, right here. That would be where it would be. And this would be, B prime would become 9, 0. So we go over 1, 1, 2, 3. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And this would B prime, and this would be A prime. And so C prime would be 12, -3. So I'm going to go over 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, and this would be C prime. And so now when I connect this shape, you can kind of see that it's 3 times the size, right? It's 3 times the size, dilated about a point that is not in the origin, right? So this triangle is 3 times this triangle. You could easily calculate it, right? It's up 2 over 2, so it's up 2 over 2, up 2 over 2, up 2 over 2. It is 3 times the slopes change, so that's kind of interesting. So we'll stop it there.